In our last video, we looked over manipulating algebraic fractions, and we went over a few examples. And today we're going to continue our discussion on manipulating algebraic fractions. And I'm going to give you a few more examples that we can go over that are going to include some more advanced calculations and some more advanced factoring methods that we had learned in our previous videos. So let's start off with the following example. Let's say we had 16x squared y minus 8xy divided by 12x minus 6. So let's start off by first dealing with our numerator here. Now, how can we factor our numerator? Well, I can see some common factors that are present in both of these terms. Let's factor out 8xy. And if we factor out 8xy, we're going to be left with 2x minus 1. Now let's try and factor our denominator. If we're factoring our denominator, we are going to be left with, well, let's factor out 6. If we factor out 6, we're going to get 2x minus 1. This is going to be our new fraction, just writing these terms down in their factored form. And we can recognize that we have common terms here that we can cross out, and we're going to be left with 8xy over 6. And already we can see that we still have common factors in both of these terms here. So we can write this down as 2 times 4 over 2 times 3. And we have our xy at the top that we can't forget about. And because we have a 2 and a 2, those can cancel out. So we're going to be left with 4xy over 3. And that is our final answer. Now let's go over another example. Let's say we have x squared minus x minus 6 divided by x cubed minus 27. So let's first look at our numerator and see how we can factor that. We have a leading coefficient of 1 here, so again we can use that same method of finding two numbers that multiply to give us this term here, so that's negative 6, and we need them to add together to give us negative 1. So we know that one of our numbers is going to be positive and one is going to be negative, so let's write down our factors of 6. We have 6 and 1 and 2 and 3. And if we have one of them being negative and one of them being positive, well, we can see that these are going to be our numbers. So if we have negative 3 plus 2, that is going to give us negative 1. So negative 3 and plus 2 are going to be our two numbers. And negative 3 multiplied by 2 will give us negative 6, and negative 3 plus 2 will give us negative 1. So we can factor out our numerator as x minus 3 and x plus 2. Now let's look at our denominator. So let's do that down here. If we look at our denominator, what is something that we can immediately recognize about this? We can see that this is a perfect cube and this is also a perfect cube. So we have a difference between cubes here. And if you recall back to a couple videos, we can remember that the way that we're going to factor a difference of cubes is to write down our formula. And our formula is that we have a minus b multiplied by a squared plus ab plus b squared. And again, this is because we have a difference of cubes, so this is going to be a minus sign. Our second sign is the opposite sign, so it'll be plus. And in both of our formulas, with whether we were dealing with a difference or a sum of cubes, this is always going to be positive. So this is our formula here, and we know that our a is going to be equal to x, because the cubed root of x cubed is x, and our b is equal to 3, because 3 cubed will give us 27. So now we can just plug in our numbers into here. And let's just write this down at the bottom of the fraction. So if we plug in our a's and b's, we're going to be left with x minus 3 multiplied by x squared plus 3x plus 9. And again, that's just plugging in our a's and b's into this formula right here. And now we can recognize that we have an x minus 3 up here and an x minus 3 down here. Those two can cancel out. And we're going to be left with x plus 2 divided by x squared plus 3x plus 9. And now let's go over one last example here. Let's say we have x cubed plus y cubed divided by x cubed multiplied by 5x plus 5y divided by x squared plus 2xy plus y squared. And when you're looking at this, one of the first instincts you might have is to say, oh, here's an x cubed and here's an x cubed. We can just cancel these out. But you absolutely cannot do that. And the reason that you cannot do that is because we don't have a multiplication sign here. We're actually adding these two together. And if this was written as x cubed multiplied by y cubed over x cubed, we could cancel those two out. But because we have a plus sign here, we cannot cancel these out. So let's try and go through this step by step and factor each of these different parts of this expression. So let's start with this part up here. Well, we can see that this is a sum of cubes. We have two perfect cubes and we're adding them together. So immediately we can write down the factored version of this as our sum of cubes. And let's just write down our sum of cubes formula here. So when we're taking a sum of cubes, we're going to have a plus b multiplied by a squared minus ab plus b squared. And here our a is equal to x and our b is equal to y. So we can write down this as x plus y multiplied by x squared minus xy plus y squared. Now let's try to factor this part right here. So we're going to keep our multiplication sign, and if we factor out the 5, we're going to be left with x plus y. Well, this x cubed can't be factored further, so let's just keep this x cubed as an x cubed for now. And we have our multiplication sign there. And now let's try and factor this part here. Now when we're trying to factor this expression here, you might have to just look at this and think outside the box a little bit. And one of the methods that comes to mind is factoring by grouping in pairs. So let's try and write this expression down into a format where we can group in pairs and see if we can make sense of it that way. So let's say if we were to break up this 2xy into xy plus xy. So let's say we have x squared plus xy plus xy plus y squared. This is exactly the same thing as this. We've just broken up our 2xy into xy plus xy. And now if we were to factor this by grouping in pairs, we can factor in these two groups. So let's take an x out of here. We'd be left with x plus y. And let's take a y out of here, and we'd be left with x plus y. And now we can see that we have x plus y as a common factor, so we can factor out our x plus y, and we're left with x plus y again. And this is the same thing as x plus y squared. So we can factor this expression in blue as x plus y squared. So I'm just going to give myself a little bit more space here. Let's write down what we have so far. So we have x plus y multiplied by x squared minus xy plus y squared times 5 times x plus y. And then on the denominator, we have x cubed times x plus y squared. And again, this is just rewriting our numerator and our denominator. Let's go ahead and actually multiply out this numerator and simplify it further. Let me just scroll down and give ourselves some more space. So our numerator can be further simplified by, we're multiplying the whole thing by 5. We have x plus y and x plus y, so this would be 5x plus y squared. And then our expression here, we're also multiplying that. So we have x squared minus xy plus y squared. And in the denominator, let's just clear this up. In the denominator, we have x cubed multiplied by x plus y squared. And now we can see that we have common terms in the numerator and denominator that we can cancel out. So we have an x plus y squared on the numerator and denominator that'll cancel out. And we are going to be left with 5 times x squared minus xy plus y squared divided by x cubed. And that is our final answer.